Hello everyone, this is Charu here, and today we are going to start the fourth video lecture of our chapter Geometry. So now, this is the mind map of our chapter, and today the topics which we are going to cover is circle, the parts of circle, radius, diameter, center, circumference, relation, diameter is equal to twice the radius. This is very important relation. Next is chord. Then after the chord we will read about symmetry. Symmetry, then the mirror images. Then last about shapes, solids, cylinder, cuboid, cube and their views, top view, front view and the side view. Let us start with circle. So what is a circle now? The locus of points that are the same distance from a center. Locus means the collection of points. Now suppose this is a center and this is a one point. If we will take or any such points which are at the same distance from the center, then their locus or their collection forms the circle. So this is a circle with center. Now let us read more about circle and its parts. So our first part is center. What is center of circle? This fixed point inside the circle is known as its center. In the given figure, A is called the center of the circle. But more accurately, the center of circle is that point where the metal arm of the compass is placed while drawing the circle. So this point where metal arm of the compass is placed is called center of the circle. Here O is the center of circle. We call a circle by the name of its center. For example, here also O is the center of circle. Now, our second part of the circle is radius. Now, what is radius? If we join any point on the circle to the center of circle, we get a line segment. This line segment is called radius of circle. Let me show you. If we join any point of the circle to the center of the circle, we get a line segment. This line segment is called the radius of the circle. So, here OP and OM, OR, these are the radius of the circle. OP, OM and OR are three radius of circle, so we call it radii. Radii is a plural of radius. Here mentioned, radii is a plural of radius. So this circle has three radii, OP, OR and OM. Now, if you measure OP, OM and OR, if you will measure it by scale, you will find that they have same length. This is the length of the radius of circle O. Now if you will measure all the length of this OP, OR and OM, these are same and it will be the length of the radius of circle. Now our next part of circle is a chord. What is the chord? If any 2 points on a circle are joined, for example, here A and B are the 2 points on the circle. When they are joined, we get a line segment. This is called the chord of the circle. Now this line segment AB is called the chord of the circle. Now this is a circle with center O, and here AB and CD are the chords of the circle O. AB and CD are the two chords of the circle. A circle can have many chords. A chord have different lengths. A circle can have many number of chords and that of different lengths. Now, our next part is diameter. What is diameter? A chord of a circle which passes through its center is called diameter. Now, any chord of circle which pass through the center of circle. So, this is called diameter. Here, MN and PQ are the two chords. So these are passing from center O. So these are called diameters of circle. That means here MN and PQ are the diameter of circle O. A circle can have many diameters. All diameters have the same length. So, length of MN is equal to length of PQ. Now, in the given circle alongside, in this circle, M is the center of circle and MN is the radius of circle. PQ is the chord of circle and AB is the diameter of circle. Here written, M is the center, MN radius, PQ chord of the circle and AB diameter of the circle. Now next question is, are there other radii in the figure? Yes, MA and MB. Let us see. MA and MB. These are the radii of the circle. Is there any other chord in the figure? Yes. AB, the diameter is also a chord. AB is a diameter of circle because it passed through the center. But this is a chord of circle also because it joined 2 points of the circle. So diameter is a chord. So things to remember, every diameter is a chord, but every chord is not a diameter. How? Now, every diameter is a chord because diameter also join 2 points of the circle. But every chord of circle does not pass through center. For example, here PQ, it does not pass through the center of circle. So PQ is a chord but not diameter. The diameter is the longest chord of circle. And number third, a circle has many radii, chords and diameter, but it has only one center. So these are the properties of circle about diameter, chord and radii. Now our next property is circumference. What is circumference? The length of the boundary of a circle is called the circumference of the circle. This length of the boundary of circle, this whole length of the boundary of circle is called its circumference. Now we have read about center of circle, radius of circle and diameter of circle. Do you know there is a relation between radius and the diameter of circle? Let us find out the relation. Now, this is a circle with center O and diameter AB. And how AB is formed? Here AB is equal to AO plus OB, where AO and OB are the radii of circle O. So AB is equal to radius plus radius. Clear? So here AB is the diameter. What do we get? Diameter is equal to radius plus radius, which is equal to twice the radius. Again, look at this figure. Look at the figure given below. You can see that AB is the diameter of circle O. Here AB is equal to AO plus OB. AO and OB are the radii of the circle. So AB is equal to radius plus radius. Here AB is the diameter. So what we get? Diameter is equal to radius plus radius, which is equal to twice the radius. That means 2 times. Hence we get our relation. Diameter is equal to 2 times the radius. This is the required relation. Diameter is equal to 2 times the radius. So D is equal to 2R, where D is the diameter and R is the radius. So what kind of questions we are going to do in this exercise? Like this. We have given a circle and we have to write its center. Now center of the circle is G. Very good. Radius PG. This green line is the radius. Next, this GP can also be the radius and GS can also be the radius. So we can write any. Next, chord XT is the chord. Number 4th is diameter. Now, what is diameter? A line which passes through the center of the circle. So here PS is the diameter. So now what all we can find? Center, radius, chord and diameter of the circle. Now our next topic is symmetry. So in symmetry we are going to read symmetrical figures, asymmetrical figures and line of symmetry. Now if we fold a figure on the dotted line and one part will exactly fit over the other part, such figures are called symmetric figures. So that means when along this line you will fold the one part of the figure like this over the other and it exactly fit. So these figures are called symmetrical figures when one half completely covers the other half. And this line along which we are folding it is called line of symmetry. So what is the line of symmetry? The line of symmetry is an imaginary line. This is not a real line, just dotted imaginary line where you could fold a shape or image and have both halves match exactly. That along that line, when you fold the image, it exactly fit over the each other. So that imaginary line or dotted line is called line of symmetry. So it can be of either kind, horizontal line of symmetry or vertical line of symmetry. It can be slanting line also. So are all the figures symmetrical? No. Some figures are symmetrical, that is, we can draw the line of symmetry like this, a rectangle. A rectangle can have vertical line of symmetry also and horizontal line of symmetry also. Similarly, H, this sphere and this figure. So they have two lines of symmetry. But some figures cannot have even a single line of symmetry. So such figures are called asymmetrical figures or figures which are not symmetrical. So these are the examples of asymmetrical figures. That means, so these are the asymmetrical figures. And they are the symmetrical figures. Now, our next topic is the mirror image. Now, when you look at the mirror, you see your own image, and this is called a reflection. The reflection is at same distance from the mirror as you are. Always the difference between the object and the reflection. Now here, this is the object, this is the mirror, and this is the reflection. So distance between the object and the mirror and reflection and the mirror is always same. Now these all are the mirror images. M, B, this triangle and the last figure. So these are the mirror images of each other, and in the mirror images, what we are getting? This is our reflection. Similarly, what can you say about them? These are the reflections? These are reflections? No, these are not the reflections. These are just rotated from left to right. So these are the rotations only. Rotations, not the reflection. Now next is the exercise. Now let us see some lines of symmetry. Here, first of all, in maths, M has one line of symmetry, A has also one line of symmetry, T also with one, and H has two lines of symmetry. Now what about our mathematical geometrical figures? They can also have lines of symmetry. So this is a square with the vertical line of symmetry, as well as it can have horizontal also. Similarly, a circle also, a circle can have many lines of symmetry, as well as our rectangle. And these are the mirror images or the reflection of the letters of English alphabet. So all these are the mirror images of each other. Now our next topic is the three-dimensional shapes, or we named as solid. So a three-dimensional or 3D shape is a solid which encloses a volume, which has a volume and has a length, breadth and height. Now they have three dimensions. These solids. So our first solid is a cube. An ice cube, sugar cube, dice, these all are the examples of a cube. Now a cube has 6 faces, 12 edges and 8 vertices. And all the 6 faces of cube are squares. Now let us see about cube in detail. A cube is a three-dimensional figure which is having 6 faces, 12 edges and 8 vertices. Now the shaded part is called the face of cube. In total, cube has 6 faces: left, right, top, bottom, front and back. Then edges. Now what are the edges? These green lines, these boundaries of the sides are called edges. And the vertices are the corner points. So these are the edges, faces and vertices of the cube. Similarly, second example of solids is cuboid. A cuboid also has 6 faces, 8 vertices and 12 edges. Same as cuboid, same as that of a cube too. Then what is the difference between cube and cuboid? Now let us see. A cube has 8 vertices, a cuboid has 8 vertices. Similarly, a cube has 12 edges and a cuboid also have 2 equal length. 6 faces, 6 faces. So the main difference is the face of those figures. A cube has square faces and a cuboid has rectangular faces. That means a cube has a square face, whereas cuboid has a rectangle face. So this is the major difference between the both cube and the cuboid. Can you think of any example of cuboid? Bricks, ice cream bricks. These are the examples of cuboid. Whereas dice, sugar cubes, ice, these are the examples of cubes. Now we will observe the views of these 3D shapes. That means their front view, how it look when we are watching it from the front, from the top view and the side views. Now let us see. If we look at an ice cube from the top, front and side, what do we see? Ice cube. From the top view also square, front view, side view. You can see in the cube also. All the sides, all the faces are square only. So all the 3 views are square. Similarly, what happens when we look at a brick from different angles? Now, imagine a brick. So this is the top view, this is the front view and this is the side view. And all the views are different. Try to look at some objects around you from different angles. For example, lunchbox, water bottle, book, top of the table and whiteboard, so on. And observe how they look. Now see, this is a brick. Now what are the 3 views? This is our front view. This is our side view, this side. And this is our top view. See the top. This is the top. So similarly here all the 3 views are different. This is the example of your brick. Now we can easily understand. Similarly, if we talk about cylinder. So what is the top view of the cylinder? If you will see cylinder from the top, what will you see? This face. And this is our circle. So the top view of the cylinder is our circle. Similarly here in bottle, the mouth of bottle. So these are the top, front and side views of the figures. Now, two types of shapes we have read in our geometry. Two-dimensional shape like square, rectangle, our triangle, circle. These all are called two-dimensional shapes. And now what we have read is solids. These are called three-dimensional space. That is our cube, cuboid, etc. So these are the 3D figures. Our 2D shapes are flat shapes. That means flat shapes are called two-dimensional shapes. And cuboid, cube, cylinder, sphere, cone. These are called 3D shapes or solids. What is the difference between the two? They have volume also. They are not empty, they are filled inside it. So now what all we have done in our this video? The parts of circle, center, radius, chord, diameter, our line of symmetry or symmetrical or asymmetrical figures, mirror images, difference between the cube and cuboid, their vertices, edges and faces. These are the main parts. Then the 3D views, top, front and side view, about two-dimensional shape and three-dimensional solids. So with all these topics, our chapter 8 geometry is finished now. So do revise the chapter, do read again, practice the questions. Then till then we will meet to our next